before and after for the inelastic demand curve, and then I'm going to compare consumer surplus before and after for the elastic demand curve. So let's do that. Whew, this is stressful. Let's do it. I'm very focused today. I shouldn't have said that. It's all going to go south now. Okay, so the way to do this, and we'll see lots of these, and I have a better way of drawing this in a little while, but essentially what I want to figure out is what is consumer surplus at P star, what is consumer surplus at P double star, and I want to look at delta. By delta, I don't mean the estuary system north here, I mean the change. So here we go. A little table drawn by hand. So let's look at the easier one first, okay, at D1. So D1 at P star, consumer surplus is going to be the triangle at P star for D1, right? This demand curve here. This is the price. This is equilibrium quantity right here. So consumer surplus is going to be the area above price, below this demand curve, to the left of equilibrium quantity. So I'm going to slice this thing up a little bit. I'm going to call this little triangle here A. I'm going to call this shape here B, this thing up here C, and this little area here D, okay? So B is going to be this thing, D is this little triangle right here, A is this little triangle, and C is this big weird trapezoid-looking thing, right? So A, B, C, and D. So what's consumer surplus? At P star, if the demand curve is D1, area above price, below demand, over range of consumption, is going to be A plus B plus C plus D, all right? So A plus B plus C plus D. Now if price rises from P star to P double star, what's my new equilibrium quantity? My new equilibrium quantity is now, I'm just quickly going to draw it and then erase it, okay, so don't draw it. But my new equilibrium quantity is going to be this thing right here, right, where price equals demand here. So the new price is this, new quantity is this, demand is this. So consumer surplus after the price hike is the area above price, over the range of consumption, below demand, so it's going to be A plus C. So the change is, before the price rise, I had A, B, C, and D. Now I only have A and C. So what do I lose? I lose B and D. Minus B minus D. So consumers are worse off from a price hike. I mean, that's pretty intuitive. You lose welfare, right? So let's look at this again, but let's look at this for the D2 folks, all right? The D2 folks have more elastic demand. Under the original price, what you had was this price, this, so the red line here is price, this is the range of consumption, and the demand curve now, the relevant one, is this one. So consumer surplus is the area under demand, over the range of production, consumption, above price, so it's going to be A plus B for the more elastic people. After the price rise, what happens, right? After the price rise, price is this high, this is demand, so how much are the D2 consumers consuming? They're consuming this much. Right? So this is the new price, this is the demand curve here, and this is the range of consumption, so the area above price, below demand, over the range of consumption is just going to be A. So how much do they lose? They had A and B, now they just have A, so they lose B. So the big question here, this is a test of the yoga theorem again. Who loses more? So the inelastic people lose B and D. The elastic people lose B. Who loses more? The inelastic people. Say it loud, right? The inelastic people lose more. So who suffers more in yoga classes? Max, right? Terribly inelastic, which is why I quit the sport. It's not a sport, it's a lifestyle, I know. But the point here is pretty simple again, right? So from a price increase, if we start at the same quantity pricing combination, the group of people who have the more elastic demand curve are going to lose less consumer surplus than the people with the less elastic demand curve. I think I may have just misspoken, so let me make sure I said that right. The people who have the less elastic demand curve lose more than the people with the more elastic demand curve, all right? And we're going to play with this a lot more. I'm going to draw you an absolutely crazy picture with taxes in it shortly that's going to make you wish you didn't take an economics class. All right, aren't you excited? Producer surplus. So consumers walk home with a whole bunch of surplus, right? So the difference between what you're willing to pay and what you actually have to pay. Producers, turns out, are also going to walk home with a bunch of surplus, all right? So it's not just consumers that benefit from participating in the market, it's also producers. So producer surplus, we're going to define as the difference for each incremental unit between the price and the minimum amount necessary for the seller to produce good. And by minimum amount, I mean the minimum dollar amount, right? So what this is going to be is how does the producer figure out whether to produce that additional unit or not? The producer looks at his or her marginal cost curve, and if we're in an area where price is above minimum average variable cost, as long as price is equal to marginal cost, which is where he or she sets his or her output, that's where he produces, all right? So what this is going to be, producer surplus, is going to be, at any given quantity, the difference between price and the supply curve you're talking about, right? Depending on whether you're in the short run or the long run, up until the quantity sold. Now this is going to, as we see shortly, relate to profit, right? Part of this is going to be a profit story to a certain degree, but it's not exactly equal to profit. All right, so let's figure this out. Producer surplus. So for the firm, this is dollars. This is quantity. I'm going to draw a supply curve that comes straight out of the origin, right? So assume that minimum average variable costs are 0 to make it easier. So we're not going to draw some crazy complicated thing. So what I'm going to say is you have a supply curve that looks something like this, just to make life easier. It could be a straight line like we've been drawing it, but here comes straight out of the origin, all right? If equilibrium price, so this here is 1, 2, 3, 4, 4, 5. This here is going to be 1, 2, 3, 4, 5. If equilibrium price is going to be $4, we want to figure out what producer surplus is. Let's call this P star. It's $4. So at what price is this producer willing to pay to actually produce the first unit? $1, right? As long as price is at $1 or higher, he or she is willing to produce that unit. How many dollars does the producer get for that first unit, though? Oh, is the producer happy? Doing a little happy dance, right? Maserati, here I come. Okay, so the producer gets $3, even though it only would have taken him $1 to produce a unit, or the marginal cost of producing that one unit is $1, right? So what about the next unit, right? For the next unit, marginal costs are going up because marginal product is dropping. So the marginal cost of production is $2. As long as price is above $2, the producer will produce it. So here equilibrium price is $4. So he gets $4 for that second unit, but the marginal cost of production is 2. So he gets $2 of producer surplus. For the third unit, if marginal cost is $3, gets $4, so he gets another $1 of producer surplus. And let's say he chooses to produce 4 units, where for the last unit, he doesn't get any producer surplus because marginal cost is exactly equal to price, which is the optimal output level for the firm. So how much producer surplus does the individual walk away with? 1, 2, 3, 4, 5, $6, right? It's the area above supply over the range of production below price. So producer surplus is $6. Pretty easy, right? So consumer surplus is the area below demand, above price over the range of consumption. Producer surplus is the area below price, above supply over the range of production, right? I want to try and convince you of one more thing. This one's a little bit tricky, and I think Kyle didn't do this because he didn't want to explain this one. And I don't really want to explain it either, but I'm going to try anyway because you know I'm kind of silly, all right? So let's try and explain this. If you've had integrals somewhere and you remember what they are, this is easy, right? If you don't remember what integrals are, this may be a little bit tricky. So I want to figure out, right, what the area of this whole square in this case is, right? So how high is it? It's $p high. And how wide is it? It's Q star units wide. So the area of that rectangle right there is price times quantity. It's total revenue, right? So what I've got here is part of that square right here is going to be producer surplus. So the question I want to answer is, well, what's the rest of that square, right? It's going to be some sort of cost. So what is this? Let's turn this into a couple of slices here. Right? We have $1 here, $1 here. What are these blue dollar slices? Well, this is the marginal cost of producing the first unit, right? This here is the marginal cost of producing the second unit. This here is the marginal cost of producing the third unit. This here is the marginal cost of producing the fourth unit, right? We know that marginal costs are the additional variable costs. It's the change in variable costs of producing one more unit, right? So marginal cost is the change in variable costs of producing one more unit. In the long run, that's equal to the change in total costs from producing one more unit, right? But in the short run, let's stick with the long run for a second. So if this here is the change in variable cost of going from 0 to 1, I add to it $2 of the change in total variable cost of going from 1 to 2, so now it's $3. Now I'm producing one more unit, I'm adding the change in variable cost to producing that third unit, adding another $3. And now to it, I'm adding another $4 of the change in variable costs from producing that fourth unit. So this is variable cost of producing the first unit. This is additional variable cost of producing the second unit. This is additional variable cost of producing the third unit. This is additional variable cost of producing the fourth unit. So what do you think the blue squares, if I add them all up, right? All 10 of them are $1 for you if you get it right. Did you raise your hand? You go. No, you there. You're right there. I love it. You earned $1. All right, now I have to find $1. I'm going to have to incur some variable search costs here to find $1. But you're absolutely right, right? So the area under the supply curve, under the supply curve up to the equilibrium quantity produced, that's going to be total variable costs. Is total variable cost always exactly equal to total cost? Here you go, Mark. Is in the short run total variable cost the same thing as total cost? No, right? Is in the long run total variable cost the same thing as total cost? You guys are learning stuff. I'm loving it, all right? So what we've got here is let's say we're in the long run, right? The blue area here is going to be total variable cost, or total cost of producing 4 units. The whole square here is total revenue. The red stuff is then going to be, well, what's left over of the square, meaning total revenue minus total cost. What's total revenue minus total cost? Profit, right? So in the long run, this producer surplus right here is profit. That's true. In the short run, there's something that gets in the way. And that little thing is fixed costs, right? So in the long run, producer surplus is exactly equal to profits. In the short run, producer surplus isn't exactly equal to profits. It's slightly different, all right? So in the short run, what you have is there's this fixed costs thing that gets in the way here. That producer surplus isn't exactly equal to profits because you're missing fixed costs out of it, right? But I think the intuition makes sense here. If you just stick to the long run for a second, the reward for producers of participating in the markets is going to be profits, right? In the long run. And I think that's a good way of thinking about it. It's measured in dollars. It's a quantity that we can understand. And most importantly, it's measured in the same units as consumer surplus, which is dollars. So what I showed you is producer surplus for the firm. For the market, this looks very similar. So if we continue our price line over here at $4 over to the market, okay, this continues to be P star. Let's draw some market supply curve. Okay, if this is supply for the market, well, it says market on top of the graph. Good job, Max. So if this is the market supply curve here that I just randomly made up, what I'm going to get is the first thing you're going to have to look at, how much are these firms going to produce? They're going to set marginal costs equal to price since these are competitive firms. So this here is going to be Q star. Producer surplus is going to be the area below price, above supply, over the range of production. So producer surplus, again in red here, is going to be this total area right here. The area under the supply curve is going to be, again, variable cost. So let's draw it in blue like we did in the other picture. So this area right here is total variable costs for the whole industry. Right? If we're in the long run, and this is the market, then the red line, the red area here is going to be total industry profits. Pretty convenient quantity. Again, keeping in mind in the back of our heads what Max was always talking about is economic profits, where we're paying for the full opportunity cost of all resources employed in production, which is different from what accountants do. Accountants don't use opportunity costs in those settings. Okay, so that's producer surplus. It's the same as profit in the long run. In the short run, it's different by the amount of fixed costs. So this is exciting. Now, the last thing I need, right? Why is Max waving his hands and getting all excited? He even did a little performance happy dance earlier. That was exciting. Welfare. I need a measure, and this is the goal of this whole exercise, of how well off society is in any given price-quantity combination in a market. So my measure of welfare here, which you can use as societal well-being, is simply going to be the sum of consumer and producer surplus for any price-quantity combination in a market. All right? So welfare here is often used. The word welfare, of course, has two meanings. Right here, I don't mean social programs. Here, I mean well-being of a society, where I'm simply going to look at any given price and quantity in a market. I'm going to add in dollars how much consumer surplus consumers get to how much in dollars producers get in terms of producer surplus, add the two, and that I'm going to call welfare. Now, why do we like it? It has several advantages. Number one, again, it's measured in dollars. Number two, it measures the well-being of consumers and producers equally, right? It also measures the well-being of individual consumers equally, right? A dollar is a dollar, right? Some people's dollars aren't weighted more heavily than other people's dollars. And what I'm going to show you, and that is going to, that gave rise to whole news networks, right, is this claim that producing less than the perfectly competitive level, meaning if you have a perfectly competitive market and you somehow perturb it so it produces less or more than the perfectly competitive outcome, that reduces welfare relative to leaving the market alone and having it produce the perfectly competitive equilibrium, right? So if we have a perfectly competitive market, somehow forcing it below the equilibrium quantity or above the equilibrium quantity it would land on in the absence of government intervention is going to make things worse off. I'm going to show you that that's true. And you're already getting slightly angry. I'm feeling blood pressures elevate. If we all had eye watches, I could plot your blood pressures on the screen most likely, but those aren't out yet, I guess. But the point here is, the underlying assumption here is if the market is perfectly competitive. So this statement will be true if you have a truly competitive market and you shove it away from equilibrium, society is going to be worse off, all right? In terms of this measure of welfare. Does my measure of welfare say anything about distribution of income? No, right? Nothing at all. It just adds across all consumers, overall consumer surplus. So if one guy gets all the well-being, all the consumer surplus, that's the same thing to me as if I have the same amount of consumer surplus equally distributed across all individuals. So what I want to make sure here is I am not going to be very good about telling you anything about inequality or the distribution of income. There's a guy, you may have heard of him, made a movie, Secretary of Labor, really nice man, really smart, works right up the hill here. Robert Reich, you've all taken his class, I hope. He has a lot more to say about that than I do. So what I'm going to talk a lot about is about maximizing the size of the pie, right, given our limited resources. And what he talks about very eloquently and very clearly is how do we divide up the pie, right? How big is the slice that every individual gets of that pie? I am not good at that, and the theories I'm teaching you here have very little to say about that, since that really depends on what kind of social welfare criteria we're going to apply here, all right? But let me show you that as a whole, right, the pie is going to be smaller if we take a competitive market and we shove it away from what the equilibrium would be if you were to leave it alone, all right? This is a cool picture. Whew, all right. Price, quantity. I need a serious pen here. Blue is just not the most serious of colors. Let me draw you a perfectly competitive market. It's a thing of beauty. This little thing right here, demand curve. This little thing right here, supply curve. If the market is left alone, the market will produce, that's terrible. Try that again. The market will produce Q star units of output, and the equilibrium price you will observe in the market will be P star dollars. Now, if I take some policy, and we're going to examine a number of policies that do that, but just a random policy which pushes the market below the equilibrium quantity, let's say to Q double star, consumers are willing to pay a higher price here, so this is going to be the equilibrium price. The question I want to ask is, what happens to welfare, right? What's welfare at P star Q star, meaning what's the sum of consumer surplus and producer surplus at P star Q star? And how does that compare to the sum of consumer surplus and producer surplus at P double star Q double star? There's a star missing at the bottom here. So let's do it, all right? Let's figure it out. I'm going to come up with some pizza slices that are very convenient here. A, B, C, D, and E, all right? I'm going to look at consumer surplus, producer surplus, and W is for welfare, the sum of the two. And I'm going to compare the perfectly competitive outcome, the market left alone, to Q double star, where we force the market to a lower equilibrium quantity, all right? So at Q star, P star, which is where quantity supplied equals quantity demanded, that's the equilibrium outcome the market were to reach if you left it alone. So P star, Q star, let's do consumer surplus first. It's the area below demand, above equilibrium price, over the range of consumption, so it's going to be A plus B plus D. Producer surplus here is going to be the area above supply, below price, over the range of production. So it's going to be this triangle right here. It's going to be C plus E.